quick review on how to add vectors. Let's draw what happens here. A person drives 5 miles, 3 miles, and 9 miles at different directions. So a person I'm going to draw an XY axis or a north-south axis. A person drives, let's see, 5 miles at 50 degrees. Then they drive 3 miles east, and then they drive 9 miles south to the east, let's say at 60 degrees. Well, what does 60 degrees south of east mean? Where are you going to put that? How are you going to draw that? Understand, you can draw a north-south axis anywhere, so I'll just draw another one there. South of east is going to be this way, and I'm going to draw it at 60 degrees. I'm going to make it almost twice as long as this vector here. So this is 60 degrees, and this is 9 miles. All right, so there's pretty much our layout of what the person did, how they traveled. I want to know what the total displacement is. That's a total displacement. Now, how do I find what that answer is? I can measure this with a ruler, but since I didn't measure any of the other ones, this is just a general picture. So how do mathematically I figure out what this line is? It's simple. I have to get rid of my vectors that are not on the XY axis. So the first vector I want to get rid of is I want to get rid of this vector here. I can replace it with this vector and this vector. This is going to be hypotenuse sine theta. This is going to be hypotenuse cosine theta. So really quickly in my calculator, I'm going to put in 5 times sine of 50 degrees. So that's 3.8. 3.8 miles. And what is going to be the x component is going to be 5 cosine 50. This is 3.2. Now I can get rid of that original vector I have. I've replaced it with these 2 vectors. It's the same thing. I can't leave 3 vectors up there because there's not 3 vectors. There was a vector that was 5 miles, 50 degrees of north. I replaced that vector with the x and y component. So erase, scratch out, get rid of that other vector. It no longer exists because it's been replaced by its twins. 3 miles east, it's already on the x-axis, so I don't have to replace it with its x, its x and y components. Now this vector here is running not on the x and y axis. I have to replace it because I can only add x vectors to x and y vectors to y. So how would I find this out? Let me break into the vector this way. This vector here. This vector here. I know that's 60 degrees. So what is the opposite? The opposite is sine theta, hypotenuse, sine theta.
Mr. Haney, please call 2007. Mr. Haney, 2007.
This is the hypotenuse cosine theta. Again, here's the angle I have. This is the opposite, this is the adjacent. Mathematically, I throw my calculator, hypotenuse is 9 times sine 60 degrees. 7.8. And this will be hypotenuse cosine theta. So that's 9 cosine 60 degrees. This is 4.5. That's not very good. That looks like a 45-degree angle, so it's not really drawn well in scale. But now I can get rid of this, because I replaced that vector that's not on the xy axis. I cannot add vectors that are not on the xy axis. They have to be on the x-axis to add to x's, and the y-axis so I can add to y's. So, how am I going to get my resultant? I'm going to write resultant in the x direction is equal to 3.2 plus 3 plus 4.5. That's 6.2, that'd be 7.7, right? 3, 6, that's 10. 3 and 3 is 6, plus 4 is 10.7 miles. That's in the x direction. How about the resultant in the y direction? It's going to be 3.8 plus negative 7.8. So that's going to give me a negative 4. Yep. Again, it's 3.8 plus 7.8 or plus negative 7.8 gives me a negative 4 as a resultant. So what does this mean? It means I can replace all this with a vector that is 10 this way and 4 this way. So my resultant vector should look something like that. And the big question is, does it? This vector looks just like that vector. So, once again, vectors are meant to be moved around and manipulated just like they are here. So what's this? If this is 10.7 and this is 4, I go 10.7 squared, so the resultant is equal to 10.7 squared plus 4 squared. And I take the square root because this is in the form of a squared plus b squared is equal to c squared. Of course, the resultant is the c squared in this case. This is just the Pythagorean theorem. We've done this over and over again. So 10.7 squared plus 4 squared equals find the square root. And I get 11.4. So this is 11.4 miles. What's this angle? This angle is, I usually use the TOA. This is the opposite, this is adjacent. So tangent theta is equal to opposite over the adjacent. Theta is equal to tangent negative 1, the inverse tangent because I brought it across, opposite over the adjacent. So antitangent or arctangent 4 divided by 10.7. I've got 20.5 degrees. So again, what I started off with someone that was walking 5 miles this way, 3 miles this way, and 9 miles this way. I was looking for that, and I have it right here. Okay, this line is this line. So I did it mathematically. I didn't have to bring out my protractor. My answer is 11.4 miles, 20.5 degrees south of east. A little cumbersome, but try to deal with it.